Okay, here we are once again simplifying expressions, and there are negative values under the radical, meaning we are going to have I most likely in our answer. In this first one, I'm going to break down the square root of negative 6 as I square root 6, and the same thing for the square root of negative 15. I square root just regular 15. That just breaks out the negative, so we can just deal with the square root of 6 times the square root of 15. The cool thing about multiplying radicals is that you can just multiply regularly. It's just under a square root. So 6 times 15 is just 90. So the square root of 6 times the square root of 15 is just the square root of 90. And I times I is I squared. The interesting thing here is that I squared is actually a real number. It is actually -1. So I'm going to write that in the next line. Then we're going to break down the square root of 90 into its perfect square factor of 9. And of course 9 times 10 is 90. Alright, I'm going to bring down that -1 once again, and the square root of 9 is 3. Square root of 10 cannot change. -1 times 3 is just -3 square root 10. So as you can see, not every single time when you have negatives under the radical to start will you have an I in your final answer, and that's just because I squared actually is real and it's just -1. Let's take a look at our red problem over here. Let's do the same thing we did as before. So I'm going to break down the square root of -45 is just I square root 45, and the same thing in the denominator. And the great thing about 45 is that this one's pretty easy. It actually deals with the 9 again. So we have square root 9 square root 5 over I square root 5. If you take a look from top to bottom, the i's cancel and so do the rad 5's, and we're actually just left with the square root of 9, which is 3.